My name is B. Rabu, rule number 244G1A0587, Banks SCBA section. The topic name is Gauss diversion theorem. Subject name TVC, subject code 23MAT02. Gauss diversion theorem. The given question is verify Gauss diversion theorem F bar equal to x cube minus yz I bar minus 2x square y j bar plus zk bar taken over the surface of the cube bounded by the planes x equal to y equal to z equal to 0 and the coordinate planes. Solution. Gauss diversion theorem. Integral over v del dot f bar dv equal to integral over s in f bar dot n bar ds taken LHS equal to integral over v del dot f bar dv del dot f bar dv equal to dy dx of x cube minus yz plus dy dy of minus 2x square y plus dy dz of z del dot f bar equal to 3x square minus 2x square plus 1 del dot f bar equal to x square plus 1 from LHS and RHS. Integral over v del dot f bar dot f bar dot dv equal to integral over s f bar dot n bar ds. Then here the integral over v del dot f bar dv equal to integral x equal to 0 to a and y equal integral y equal to 0 to a integral z equal to 0 to a x square plus y square dx dy dz equal to integral over x equal to 0 to a and y equal to 0 to a x square z plus z dx dy integral x equal to 0 to a and y equal to 0 to a. By substituting the limits we can get x square a plus a dx dy, and now we have to integrate with respect to the y, and now we get x square equal integral over x equal to 0 to a x square ay plus ay integral over a to 0 dx. Now we can get integral x equal to 0 to a x square a square plus a square dx. Now we have to integrate with respect to the x cube plus x cube by 3 a square plus a square x over the of a and 0. By substituting the limits in the equation you can get a cube by a power 5 by 3 plus a cube, the given surface of the cube bounded by the plane x equal to y equal to z equal to a and the coordinate plane here shown the cube with the vertices z equal to a, x equal to a, y equal to a with the along the axis x, y, z respectively. Here the RHS equal to integral over s f bar dot n bar ds. Here there are 6 faces in the cube, so we have to find for the each face of the surface integral. Here the integral over f bar dot n bar equal to integral s1 of f bar dot n bar ds plus integral s2 plus integral s3 of plus integral s4 plus integral s5 integral s6, and we have to find these 6 faces. We have to get the RHS solution. They along the x-axis the faces are AB, GF and OC, DE. Along y-axis faces are CD, GB and DEFA. They are, and another axis along z-axis faces are ED, GF and OA, BC. Here from the face ABG along x-axis integral over s f bar dot n bar dx. Here the values of the x equal to a and n bar equal to I bar ds equal to dx dy. Here integral over s 1 f bar dot n bar ds equal to integral y equal to 0 to a z equal to 0 to a x cube minus yz into I bar dot n bar dy dz. Here n bar is the unit normal vector along the x-axis. Here n bar equal to I bar. Now we can substitute in the equation. We can get integral y equal to 0 to a and z equal to 0 to a x cube minus yz dy dz. And now we have to integrate with respect to the z. We can get y integral y equal to 0 to a x cube z minus y z square by 2 integral of the limits a and y. We can substitute those limits in the equation. We can get integral y equal to 0 to a power 4 minus a square by 2 into y dy into a power 4 by y by a square by 2 into y square by 2 of the limits a and 0 a power 5 minus a power 4 by 4. From the another face OCD along x-axis integral by s to f bar dot n bar ds. Here x equal to 0 and n bar equal to minus I bar, ds equal to dy dz. Here integral y equal to 0 to a and z equal to 0 to a and yz of minus x cube into dy dz. Here integral of y equal to 0 to a, can by integration with respect to the z we can get y into z square by 2 of a of 0 dy. Here by substituting the limits we can get a for 4 by 4 from the face CDGB along y axis. Here the S3 of the integral. Here y equal to a and n bar equal to j bar, ds equal to dx dz. Here x equal to 0 to a, z equal to 0 to a minus 2x square y dx dz. Now we have to substitute in the limits. After we can get x equal to integrating 0 to a minus 2x square a square dx. Now we have to substitute the limits. Y equal to minus 2a over 5 by 3 for the face OEFA along y axis. Here y equal to 0, n bar equal to minus j bar, ds equal to dx dz. Here integral s4 equal to, here integral s4 equal to 0 because we have to substitute the y equal to 0 in the equation 1. Now all the weighting anything value into 0 equal to 0, so we can get the 0. The integral 0 is could be 0 for the face EDGF along the z axis. Here integral s by, here z equal to a and n bar equal to k bar, ds equal to dx dy. Here x equal to 0 to a and y equal to a into z dx dy. Here x equal to 0 to a y of 0 y. Substituting the limits we can get integral x equal to 0 a square dx. By substituting we have to integrating further into the x, we can get a square x into we can into limits of a and 0. By substituting them we can get a cube for the face OABC along z axis. Integral x is, here z equal to 0, n bar equal to minus k bar, ds equal to dx dy. Here integral of x equal to 0 to a and y equal to 0 to z dx dy. Here integral x equal to 0 to a and over 0. Here we substitute the z equal to 0 to a in the equation, we can get 0. Anything into the 0 equal to 0. Now we have to substitute all those values in the from the equation a. We have to get the total value a power 5 minus a power 4 by 4 plus a power 4 by 4 minus 2 a power 5 by 3 plus 0 plus a cube plus 0. Can the total value we get a power 5 by 3 plus a cube. Here the LHS equal to array, hence Gauss diversion theorem is verified. Thank you.